Welcome to Danny's Maths Hub. Now, over the next 4 lessons, we are going to be looking at all the transformations we can do on a grid. Now, those 4 transformations are reflections, rotations, translations, and enlargements. And today we are going to focus on reflections. Now, when I say reflections, I'm sure most of you will think straight away when you look in the mirror before you go to school in the morning, just to check you look all right. And that's exactly what you should be thinking. That is a reflection. Okay, what it does, that reflects you into the mirror. Now, when you look into that mirror, when you raise your left hand, it looks like your reflection is actually raising their right hand, doesn't it? And the same if you raise your right, it looks like they're raising their left. And that's because it's not creating a carbon copy of you, it's reflecting you, it's giving you that mirror image. So when your hand goes forward in the mirror, your hand looks closest to the mirror and your body is further away. And it looks exactly the same in the mirror. And that's all going to be very important. Those ways we look at our reflection, that's going to be very important today because we're going to look at how we reflect shapes on a grid. Now, on our grid, we're going to put an X and a Y axis. Okay, on our X and a Y axis, our X is going to go along there and our Y is along there. Now, this can help us when we need to create our mirror lines or our reflection lines. We can use our X and Y as a reflection line. For instance, if we put a square in, if we draw our square in here, and we want to reflect it over our x-axis, so this line here, well, we need to think, how far away is this square from our reflection line, so our x-axis? Well, it's currently 1 square away, isn't it? So we know our reflection will also have to be 1 square away. Now, if we mark this corner here with an x, we know that that x has to be along this line and 1 square away, which means the other x, which was reflected, should appear here. Put an x on that corner, it will appear here. If we go to the furthest end now of our square, put an x. If we wanted to repeat that x, that would appear here, wouldn't it? And the same for the other corners, because our nearest points have to stay nearest to our middle line. So we can see when we reflect that square, it appears here, with these 2 bits lining up with those 2 bits. What we've successfully done here is we've reflected in the x-axis. Now we can do the same if we reflect in the y-axis. If we want to reflect this shape in our y-axis here, again it's 1 square away, so the reflection is going to be 1 square away, and these 2 points are going to be here, aren't they? Closest to our y-axis. Now that's all very nice and easy when we've got to do it over the x and y because we've got the lines ready drawn for us. But it can get a little bit harder. For instance, we could be asked to reflect in the y equals 1 line. So what is the y equals 1 line? Well, to find it, we simply go along our y-axis, find where y equals 1, and we draw a line. If we want to do it in the y equals minus 2, well, we stay on the y equals line, the y-axis. We find where y equals minus 2, and we draw our line. If we want to do x equals 3, well, we find out where x equals 3, which is here, and we draw our line. Okay, do you see how we're creating these lines? If it's x equals, we go along the x-axis and we draw our line. If it's y equals, go along our y-axis and we draw y equals. Now, there is one other line we could be asked to draw, and that's the y equals x. And these are the points that make up 0, 0, 1, 1, 2, 2. This is our y equals x line. Now, any of these lines could be asked to be called our reflection lines, and they would simply reflect whatever shape we're given in these lines. For example, if we're given a rectangle over here, okay, if we're given this rectangle, a 1 by 2 rectangle, and asked to reflect it in the y equals 1 line, well, let's find our y equals 1 line. It's this line here, isn't it? And we want to reflect this rectangle in the y equals 1 line. Well, these 2 nearest points, okay, which we're going to mark with an x now, have to be reflected first. They're 1 away from our reflection line. So they're going to be 1 away from our reflection line on the other side, aren't they? And if we take the 2 furthest points back, put an x on both of them, they're now 2 away. So they're going to be 2 away in our reflection line. So we're going to have our rectangle drawn here, aren't we, by joining up those key points. What we've successfully done here is we've reflected that shape in our reflection line to here. Do you notice how the shape hasn't actually changed shape? It's just changed position. So let's have a look at another one. What if it's not quite so easy? What if we have our triangle and we want to reflect this triangle in the line of x equals 1? So let's go to x equals 1, which is here. Okay, we got our x equals 1. So we draw our line. This is now our reflection line. So let's now take the 3 key points of our triangle. So we'll mark them with an x. And then we look how far each x is away from the line. Well, the first x is one away, isn't it? So we do exactly the same. The next one, how many squares away? Well, we mirror that. And the final one, we mirror that. We've taken our 3 key points from over here and we've put them over here using our mirror line. So now let's join up our key points. And what we've done, we've successfully reflected this triangle in the line of x equals 1. So let's have a look at one more. What about if we wanted to reflect this shape, this rectangle, in the line of y equals x? So let's think again what I said y equals x is. This is when the x coordinates and the y coordinates are exactly the same. So for instance, we have the point 0, 0, the point -1, -1, the point -2, -2, the point 1, 1, the point 2, 2, and the point 3, 3. This is our y equals x line. Now it's ever so slightly more tricky because we're working at a diagonal. However, let's make sure we keep all the rules exactly the same. We can see that one of the points is actually on the mirror line. So that's going to stay there, isn't it? Because it's on the mirror line. So let's mark the other 3 key points and let's measure, but this time diagonally, how far away it is from the line. We can see, as these lines are drawn, exactly how far away they are from the mirror line. So we do exactly the same amount on the other side of the mirror line, marking off the key points. So now, if we join all these key points together, can we actually see the shape stayed the same, but it's just been reflected? And it sort of looked like it's been turned a little bit, but it hasn't. It's because our line is at a diagonal. So I'm going to just leave that up there so you can see where the key points are. So to reflect any shape on a grid, the first thing you have to do is find your mirror line, whether it's the x-axis or the y-axis, or whether it's x equals or y equals. Once you have that mirror line, take the key points from your shape, work out how far away they are from each line, and then reflect them in the mirror line. If it was 1 away this side, it's going to be 1 away that side. If it was 3 away that side, it's going to be 3 away this side. And then once you've plotted all the key points, which is usually the corners, just join them all back up, and then you should have successfully reflected your shape. And that's reflection, ladies and gents. Tomorrow we are going to look at rotations, or in the next video even, we're going to look at rotations, then translations, then enlargements. If you have any questions, obviously, please do contact me. You know how to get through to me by now, so I'm not going to repeat myself, and have a great day.